Hey everyone, so welcome to another video on my channel. So today I'm going to be watching a video. It's called How Important is the Moon? So how important is the moon? The moon is quite important actually, as you wouldn't think it, because it's just rock. You know, it doesn't give off light, or it's just a floating rock. But yeah, we're gonna find out exactly how important it is. So without further ado, let's get straight into it.
Hey, 42 here. It's been almost 50 years since the Illuminati paid NASA $2 million to pay Stanley Kubrick $1 million to fake the moon landings in the Roswell car park in order to ensure the Russians gave up and didn't set up an invaluable cheese factory on the moon. Jokes aside, who even cares about the moon? What's it ever done for
I
us?
do.
It's just a big lump of rock that makes dogs bark occasionally and gets in the way of the sun, right? Well, how much influence does the moon actually have on our planet? Would life without it be much different? Let's find out. The first thing to deal with is how we came to have a moon in the first place. Now, since we haven't kept any of the receipts, we don't have a definite answer. It's possible that the Earth and Moon both just formed simultaneously from the same cluster of space junk about 4.5 billion years ago. But this doesn't explain why the moon contains so little metal compared to Earth. If both objects came from the same junk, they would both consist of the same stuff. Another idea is that it was the matter that was flung out of the Earth's crust by the force of the spinning motion that formed the moon.
So basically the moon was our leftovers. So let's say we have Earth and we have nothing. So this is going to be the moon. So this is Earth, and the Earth is like, I don't want like this rock, blah blah blah, just throw it all away, throw it all. And then all of this travel came together to form the moon. So the moon is basically our leftovers. Okay, but why ours? Why not? Why not like every other planet? Anyway.
Round at an incredible rate and could have made the dinosaurs feel a bit unwell. Or it could have been a wandering object drifting through the galaxy. But then we would have needed a much bigger atmosphere in order to slow it down sufficiently to capture it. So, the most likely theory is that a planet about the same size of Mars, which we've named Theia, crashed into us. And while some of the mass from this other planet was added to Earth, the debris from this impact stayed in orbit around us and slowly drew together over about a year to form the moon. This happened about 50 million years after the solar system formed, and Earth was probably still partly molten at this point. This impact would have liquefied the entire surface, so when it resettled after about a day or so, there would have been no impact crater remaining. It also explains the difference in metal levels between the moon and Earth, since the metal core of Theia would have been drawn into Earth's own core, thanks to its greater mass, whilst the lighter, non-metal parts would have stayed in orbit and gone on to become the moon. So, Theia probably increased our spin rate, but if the moon hadn't stayed around, then we would have been stuck with days just 6 or 8 hours long.
Oh wow.
Meaning your average cricket match would take about a month. The moon slows us down by tidal friction. Every time it drags the oceans a few meters up the beach, not only does it spoil our sandcastles, but the friction between the water and the sea floor shaves a tiny fraction off the year. This frictional energy is transferred to the moon because it creates a tidal bulge in the oceans which runs slightly ahead of the moon, dragging it on behind it. This extra kick makes the moon accelerate whilst it slows us down.
So basically the moon controls us. So like it controls the tide. I know it can control a lot of things. You know, people, how they react, people's sleep patterns. Every time the moon controls the tide, which every time the tide washes up onto the shore, it takes a couple milliseconds off each year. So it's making it shorter, basically.
By 3 or more centimeters annually. However, the tides play a far more important role than just creating some friction. Life evolved in the oceans. given that it's much easier to survive around a warm jet of water than it is on a tiny bit of crusted over lava rock. But as you can see from looking around you, we managed to escape the oceans and get on with the messy business of living all over Earth's dry bits, sort of like X-Men. The tides played two important roles in this. Firstly, when life was forming billions of years ago, the moon was much closer to us, about half the distance it is now. So its gravitational pull would have been 4 times greater, making the tide much bigger. Molecular biologist Richard Lave says that this would have created large low tide areas which were very salty, since the sun would evaporate the water, producing an environment that protonucleic acid fragments would have needed to form into molecular strands. In other words, large salty dry bits along the coastline led to more advanced organisms. Secondly, after life had done a bit of mating and evolving in the ocean, any aquatic organisms living on the shoreline would often find itself stranded out of the water when the moon dragged the sea away from it. So it was...
I guess that's why like jellyfish and stuff are always like washed up on the beach, or, you know, you always see like on the news or on documentaries and stuff, you know, different sea life that are washed up onto the shore. Sad. They're just there again, or today. Next one. Why am I here? And then, yeah, that's it. It's all over.
Either sink or swim. Well, the opposite, I guess. Asphyxiate or breathe. Shore life had to adapt to its new 50-50 life in and out of water, and soon there were organisms that could manage without the ocean entirely. We'd still have tides without the moon, thanks to the pull of the sun, but they'd be well under half of what they are now. It's actually the combined pull of the sun and moon that creates the spring tides. So without the moon creating exceptionally strong tides, it's unlikely that evolution would have happened this fast, and we probably wouldn't be here today. This sun and moon team is also important for night vision. The moon may only be 1 in 400,000 times as bright as the sun.
You know, lions are like big cats. I don't know if it's all big cats. I think it is. Pretty sure. They have really sensitive, I know this isn't really relevant, but it's kind of relevant. They have really sensitive, what are they called? Lenses at the back of their eye, which reflects the moonlight and it bounces it back, which allows them to see in the dark. I think all cats have that. I don't think it's just big cats. But yeah, there's a cool fact.
Sun, but that tiny amount of light that it does reflect is itself thousands and thousands of times stronger than anything else in the sky. If you go out into the countryside on a moonless night, you'll realise just how little you can see without that giant lunar reflection. You'll also probably get eaten by bears, because the countryside is just awful and full of bears. And snakes. So with much darker nights, it's likely that many nocturnal creatures would have evolved much differently, like relying on other senses, such as hearing. That's not to say that there would be no night vision, though. Some species, such as the elephant hawk moth, are so well adapted to seeing in darkness that they can see colour. For humans, when it's less than half moonlight, the cones in our eyes don't have enough photons to work with, so we only use the rods, which can't sense any colour, and we only see black and white. Without the moon's assistance, we probably would have been very vulnerable once the sun went down. The final major impact that the moon has had on us is the tilt of Earth's axis.
Yeah.
Mars currently has a tilt similar to ours, about 24 degrees from the sun. But, unlike ours, Mars' axis can vary a great deal, sometimes going down to 15 and up to 35 degrees at times. Earth would do the same if it weren't for the stabilizing effect of the moon. This change in tilt would be an ecological nightmare, since it would wildly vary the seasons. Imagine having 3 years of continuous winter. Oh, that actually sounds like normal life in the north of England. Minus all the White Walkers, of course. Thanks for the view. Subscribe for more. 42.
I enjoyed that video. That was good. You see, I like science. I have a really, really, really strong passion for science. So that was really cool for me. I really liked that. Yeah, I hope you enjoyed it. Here is the channel. that where I got it from. Here's the video I just watched. Make sure you go over and check out that channel as well. They upload every Thursday and Monday. And yeah, if you enjoyed this video, make sure to like, comment, subscribe to my channel, please. I'd appreciate it. Press that notification bell to get notified when I upload. And yeah, that's it.